In this video, we are going to discuss the determinant of 3 by 3 matrix. To determine the determinant of 3 by 3 matrix, we have to break down the given matrix as the sum of 3 2 by 2 submatrices by selecting a certain row or column elements of a given matrix as the coefficient of the submatrix and eliminating the row or column where the coefficient of the submatrix belongs. For example, if matrix A equal to this 3 by 3 matrix having elements designated by A sub ij, then the determinant of matrix A, which is denoted by capital letter A inside parallelly cited vertical bars, or det dot capital letter A equal to, let's select first row elements as the coefficient of the submatrix and write the matrix as the sum of the three submatrix. That means A sub 1 1 times the determinant of the first 2 by 2 matrix. I will figure out what the matrix look like later, but now let me simply write the sum. That's plus A sub 1 2 times the second 2 by 2 matrix plus A sub 1 3 times the third 2 by 2 matrix. I left these spaces in front of each coefficient intentionally. The sign of the coefficients alternate between positive and negative depending on the position where that element is located. So the formula we use to determine the sign of the coefficient is -1 the power of I plus j, where I is the first subscript, which stands for the row where that coefficient is located, and j is the second subscript, which stands for the column where that coefficient is located. The formula for determining the sign of A sub 1 1 is -1 the power of 1 plus 1. The first one is derived from here, and this second one is derived from here. For A sub 1 2, the formula is -1 the power of the first subscript, that's 1, plus the second subscript, that's 2. And for A sub 1 3, the formula to determine its sign is -1 the power of 1 plus 3. The elements of a 2 by 2 matrix is determined simply by crossing out the row and column where the coefficient belongs. A sub 1 1 is located at row 1 and column 1 position. So when we cross out row 1 and column 1, we left with this 2 by 2 matrix. A sub 1 2 belongs to row 1 column 2. If we eliminate row 1 and column 2, we will left with A sub 2 1, A sub 2 3 in the first row, A sub 3 1, A sub 3 3 in the second row. A sub 1 3 is located at row 1 column 3. When we remove row 1 and column 3, we left with this 2 by 2 matrix. -1 the power of 1 plus 1 is -1 the power of 2. -1 the power of 2 is +1 times the remaining stuff, plus -1 the power of 1 plus 2 is -1 the power of 3. -1 the power of 3 equal to -1 times the remaining expression, plus -1 the power of 1 plus 3 is -1 the power of 4, which is equal to 1 times the last expression. As we can clearly observe here, -1 the power of I plus j alternates between +1 and -1, starting from +1 for A sub 1 1 position. So without using the formula, we can determine the sign of the coefficient by following a chessboard pattern as plus, minus, plus across a row, and plus, minus, plus down a column as well. 1 times A sub 1 1 is A sub 1 1 times the stuff remaining. Plus times negative is negative A sub 1 2 times the stuff here, plus 1 times A sub 1 3 is A sub 1 3 times the remaining expression. This is a general formula for determining the determinant of a 3 by 3 matrix. Let matrix A equal to this 3 by 3 matrix, then find the determinant of matrix A. Determinant of matrix A equal to, I can use either of these 3 rows or these 3 columns as a coefficient for the 2 by 2 matrix. Let me use row 1 as a coefficient. The sign of the coefficients will be plus for the first entry, minus for the second entry, and plus for the third entry. We already discussed the reason why the sign alternate in such fashion. So the sum of the matrices is 2 times. By crossing out row 1 and column 1, we will find 2, -2, 1, 5. Minus 1 times, again by crossing out row 1 and column 2, we left with -1, -2 in row 1 and 4, 5 in row 2, plus -3 times, -3 belongs to row 1 and column 3, So when we eliminate them, we left with negative 1, 2 in row 1 and 4, 1 in row 2, which is equal to 2 times. To determine the determinant of this 2 by 2 matrix, we have to multiply these main diagonal elements, and from this product, we have to subtract the product of the remaining 2 elements. That's 2 times 5 minus 1 times negative 2 minus 1 times negative 1 times 5 minus 4 times negative 2 plus times negative 3 is negative 3 times negative 1 times 1 minus 4 times 2, which is equal to 2 times 5 is 10 minus 1 times negative 2 is negative 2 minus 1 times negative 1 times 5 is negative 5 minus 4 times negative 2 is negative 8 minus 3 times negative 1 times 1 is negative 1 minus 4 times 2 is 8, which is again equal to 2 times 10 minus negative 2 means 10 plus 2. 10 plus 2 is 12 minus 1 times negative times negative 8 is plus 8. So negative 5 plus 8 is positive 3 minus 3 times negative 1 minus 8 is negative 9. 2 times 12 is 24 minus 1 times 3 is 3. Negative 3 times negative 9 is positive 27. 24 minus 3 is 21. 21 plus 27 is 48. So the determinant of this 3 by 3 matrix is 48. In this calculation, we used row 1 elements as the coefficient of the 2 by 2 matrix. We will find similar result by using either of the rows or the columns as the coefficient of the matrix. Let us check it by using column 2 elements as the coefficient. First, let's determine the sign of the coefficients. Starting from row 1, column 1 entry, we have to make plus, minus, plus signs. The coefficient of the first element of column 2 is minus. So the coefficient of the second element has to be plus, and the third element has to be minus. Once we determine the sign of the coefficients, we can write the sum as determinant of matrix A equal to negative 1 times. This one belongs to row 1, column 2. So crossing out row 1 and column 2 left us with negative 1, negative 2 in row 1 and 4, 5 in row 2 plus 2 times. 2 is located at the intersection of row 2 and column 2. So when we delete row 2 and column 2, we will find 2, negative 3 in row 1, 4, 5 in row 2 minus 1 times. 1 is positioned at the intersection of row 3 and column 2. Eliminating column 2 and row 3 gives us 2, negative 3 in row 1 and negative 1, negative 2 in row 2, which is equal to negative 1 times 5 minus 4 times negative 2 plus 2 times 5 minus 4 times negative 3 minus 1 times 2 times negative 2 minus negative 1 times negative 3. Negative 1 times 5 is negative 5 minus 4 times negative 2 is negative 8 plus 2 times 5 is 10 minus 4 times negative 3 is negative 12 minus 1 times 2 times negative 2 is negative 4 minus negative 1 times negative 3 is positive 3, which is equal to negative 5 minus negative 8 means plus 8. So negative 5 plus 8 is 3 plus 2 times 10 minus negative 12 means 10 plus 12. 10 plus 12 is 22 minus 1 times minus 4 minus 3 is minus 7, which is again equal to negative 1 times 3 is negative 3 plus 2 times 22 is 44. Negative 1 times negative 7 is plus 7. Negative 3 plus 44 plus 7 gives us 48, which is equal to the result we obtained above. Whichever the row or column we used as the coefficient of the submatrix, the determinant we determined has to be the same. That's 48. If the determinant of this 3 by 3 matrix is equal to 1, what's the value or values of x? Let's use row 1 elements as the coefficient of the submatrices we are gonna for. As usual, the sign of the first entry is plus, the second entry is minus, and the third entry is plus. Thus, the sum of the 3 2 by 2 matrices is 1 times the determinant of the first 2 by 2 matrix minus x times the determinant of the second matrix plus 3 times the determinant of the third matrix, which is equal to 1. Let us figure out the 3 submatrices. 1 is located at the intersection of row 1 and column 1. When we remove them, we left with 1, 2x in the first row and 0, 1 in the second row. X is located at the intersection of row 1 and column 2. Eliminating these two left us with 5, 2x in the first row and 2, 1 in the second row. The row and column associated with these three are row 1 and column 3. Crossing them out gives us 5, 1 in row 1 and 2, 0 in row 2, which is equal to 1. 1 times this determinant is the determinant itself. That's 1 times 1 minus 0 times 2x minus x times 5 times 1 minus 2 times 2x plus 3 times 5 times 0 minus 2 times 1, which is equal to 1. 1 times 1 is 1 minus 0 times 2x is 0 minus x times 1 times 5 is 5 minus 2 times 2x is 4x plus 3 times 5 times 0 is 0 minus 2 times 1 is 2, which is equal to 1. 1 minus 0 is 1 minus this x outside the bracket multiplies every stuff inside the bracket. That's x times 5 is 5x. Negative x times negative 4x is plus 4x squared. 0 minus 2 is negative 2. 3 times negative 2 is negative 6. Taking this one to the left of equality sign gives us negative 1, which is equal to 0. Let's rearrange the elements of the equation in order to express it in the standard form of quadratic equation. That's 4x squared minus 5x. 1 minus 1 is 0. 0 plus negative 6 is negative 6 equal to 0. Now we have to find two numbers. Their sum equal to negative 5, which is the coefficient of x, and their product equal to negative 24, which is the product of the coefficient of x squared and the constant. These two numbers are negative 8 and positive 3. Negative 8 times 3 is negative 24 and negative 8 plus 3 is negative 5. Next, we have to write this negative 5 as the sum of these two numbers. That's negative 8x plus 3x. So the equation becomes 4x squared minus 8x plus 3x minus 6 equal to 0. 4x is common to 4x squared and negative 8x times 4x squared divided by 4x gives us x minus 8x divided by 4x gives us 2 plus 3 is a common factor for 3x and 6 times 3x divided by 3 gives us x minus 6 divided by 3 gives us 2. X minus 2 is a common factor for these two expressions times in the first expression we left with 4x plus in the second expression we left with 3. This left-hand side expression equal to 0 only when either x minus 2 equal to 0 or 4x plus 3 equal to 0. Taking negative 2 to the right of equality gives us x equal to 2. And for this equation, taking 3 to the right of equality and dividing it by the coefficient of x gives us x equal to negative 3 over 4. Therefore, the values of x are 2 and negative 3 over 4. Finally, let's see what the matrix looks like when we substitute x by 2 and by negative 3 over 4. If x equal to 2, then the matrix becomes 1, 2, 3 in row 1, 5, 1, 2 times 2 is 4 in row 2, 2, 0, 1 in row 3. If we solve the determinant of this matrix, we will find 1. If x equal to negative 3 over 4, then the determinant becomes 1, negative 3 over 4, 3 in row 1, 5, 1, 2 times negative 3 over 4 is negative 6 over 4 in row 2, and 2, 0, 1 in row 3. Again, if we solve the determinant of this matrix, we will find 1. You can calculate the determinant by yourself. By this, I wrap up this section. I will catch you in the next episode. Bye-bye.